So like I was saying, this is the general formula for Newton's method, where to find roots of a function that is not necessarily a nice polynomial. So we're going to start off, and we're going to make a guess. We're going to call that guess x1. We want to pick an x that is close to the root because the information contained in the tangent line is only really relevant when we are very close to the x coordinate that we chose to make that tangent line, right? The function can do whatever else. If I have some function, it can just be doing its own stuff. And I can draw in a tangent line like so. This tangent line is useful information as long as I am close to the point on the curve where I drew that tangent line. This tangent line is less useful, say, somewhere else, if I get far away. Now, after I've made my initial guess, it won't be exactly right. That's the whole problem with making guesses. They won't be exactly right. Well, based on my first guess, I can make a second guess. And hopefully that second guess, using this formula right here, will be a better guess than what I started with. If that's still not close enough, I can make a third guess using the formula for a second time and so on. And I'll just keep going until my guesses are as close as I need them to be. So what am I doing here? I'm trying to build up a limit. So we're not free from limits yet. They are a very valuable tool. Here, what we're doing is we are trying to cook up a list of numbers which are getting closer and closer to something that we actually care about. Here, my list of guesses is supposed to be getting closer to some r, some root of a function that I care about. What number r can I put into this function and get 0 back out of it? I know that there should be some number like this, but in practice, it's hard to find that exactly. Okay, this has been fun and all talking about theory. Let's actually compute. Here is a function. X cubed minus 2x minus 5 equals 0. What's the root of this cubic? In this example, I'm asked to use x1 equals 2. So my starting guess is that my root here should be close to 2. Now, is that even a good guess? Well, I would have 8 for x cubed. I would be subtracting 4 for x. I'd be subtracting 5. I get -1. Well, in the grand scheme of things, -1 is pretty close to 0. So sure, why not? That seems like a fine guess. So what do we do in the method? We take the old guess and we subtract off the original function evaluated at our guess divided by the derivative of our function evaluated at the guess. So my next guess, we'll call that x sub 2, is going to be x sub 1, which is 2, minus f of 2 divided by f prime of 2. That's the formula. So our second guess here, says, let us take this original function, x cubed minus 2x minus 5, And we'll take its derivative, which is 3x squared minus 2. And we're going to build up this formula. And what do we get? Our first guess was the root should be close to 2. Our second guess now says our root should be closer to 2.1. So we got a slightly different x. Let's keep going. Our third guess is going to be I'm going to follow the same formula again. I take my second guess and I put it into this formula. So my second guess is 2.1. How much do I need to subtract off? 2.1 cubed minus twice 2.1 minus 5. That's the formula for my original function. This is all divided by 3 times 2.1, which is squared, minus 2. That's the formula for my derivative. That gets me my third guess, which is about 2.0946. Again, using a calculator is a very useful thing here. And this approximation is actually correct to 4 decimal places. So this demonstration is showing a very good use of Newton's method.